Good evening, everyone. So, welcome to my YouTube channel. So, today we are going to see second lecture on characteristics subgroup. Okay, we were studying characteristics subgroups. So, let's see today's lecture. So, today I will tell you remark that is can be individually verified. So, what is that? So, you know that for any G, the trivial subgroups identity and G. What are the trivial subgroups? Identity and throughout G. Okay, full G. Okay. They are the trivial subgroups. The trivial subgroups are characteristic subgroups. Are characteristic subgroups because for any isomorphism phi of G, we have phi E is equal to E. Okay, and phi G is equal to G. So this implies E is characteristic subgroup of G. Okay. This implies G is characteristic subgroup of G. Okay. Now we are going to see next result. So you can say theorem. If H is the unique subgroup of G of a given order, then H is characteristic subgroup of G. Let's see its proof. Okay, let H be unique subgroup of G of order n. Then for any isomorphism phi of G, we have order of of subgroup phi G phi H is also equal to order of G, that is n. It means what we have, order of phi H is equal to order of H is equal to n. So this is H here. Order of phi H is equal to order of H. You take any automorphism, then order do not change. Okay, but H is unique subgroup of G of order and phi H is also subgroup of G of order n. So what we have, H is unique subgroup of order n, and the image of H under phi is also subgroup and it has same order. So what we can say? We can say that both should be equal because H is unique subgroup of order n. We have phi H is equal to H. So this implies phi H is equal to H for any isomorphism of phi. For any isomorphism phi of G. Of G. Okay. So this implies H is characteristic subgroup of G. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture. Thank you. We will see you next lecture.